All right, we're at part B, spring elongation, and we're going to use this. This is very similar to what you did when you did the potential energy of a spring experiment. We're going to start the same, and the purpose of this is to get a spring constant K. So you're going to use this PhET Colorado.edu EN simulations mass spring lab, and you click on the play button, and it brings up the PhET simulation. Thank you, University of Colorado, to for supplying this. And let's click on energy. I think that's the best one to use. I'm going to minimize this so that you can see uh, the uh, you can see the radio buttons here on the side. So we want to be able to see the displacement. Um, it will show the mass equilibrium, and we're going to have a movable line also. Oops, I missed that. Now you're going to use the gravity of the Earth, and we're going to uh, actually for doing the spring elongation, you can um, uh, put lots of damping because that'll help you. It'll just be going back and forth if you don't use the damping. So we're going to put this, and I want you to try to use a different spring constant that you used the last time. So I'm going to uh, uh, you can use a small one or a large one. I think last time I told you set it somewhere in the middle. I'm going to set it about 75. This may limit uh, the range. Let's just see. Let's get the ruler, and I'm putting the 100 centimeters at this blue line here as close as I can. Uh, so uh, you can see that we're let's see what the range is. Uh, the range is like from 14 centimeters right here for 50 grams up to uh, 45. So we can you know we can play with this and set this at uh, 50. Let's set the this line at 15. I think that's at 15. We may not even need that. We may just use this until we get right to 15. That's a little, okay, there's 56 centimeters. I mean, 56 grams. So you put it at 56 grams. And let me record that. And that's at 15 centimeters, 0.15, and that's 56 grams. 56 grams at 15. And then, um, we've got 8. So 15 down to 45, 15, 20, 25. Let's see, starting 15, 20, 25, 30, 35, 40, 45. That only gets you to 7. But that should be good enough uh, to get your spring constant. You'll only have 7 data points, or if you want to use uh, a lighter one, I just don't want you to use your last set of data. I want you to come up with some different data. So you can set this, uh, set our set this until you get to 45, which may be the full 400, uh, 400. Yeah, there's 45, 300 grams to get you that. So just pick values in between there to come up with nice data points. You don't have to use it in multiples of 5. You can use it, um, in smaller increments, every 4 centimeters, something like that, to come up with your uh, total suspended weight versus the elongation. Okay, and so we've done this before. Just uh, use a different spring constant, uh, and that'll satisfy part B, the spring elongation for the simple harmonic motion. And we're going to come up with a K value. Then we're going to calculate the K value using oscillations. Okay, let's stop it there.